this. So what we have here, we have this question to solve a simple equation, and this is your answer. So let's look at it together. Number one says 15 minus 4x equal 2 into 3x plus 1. The first thing we need to do is to open the bracket on the right hand side. 2 is going to multiply the 2 times in the bracket. So if the 2 multiply the 2 times in the bracket, we're going to have 2 times 3x, that is 6x, and 2 times 1 gives us 2, and they are both positives. The one on the left hand side will be rewritten just like that. That is 15 minus 4x. Now we can see that there is a term with x here, another term with x here on the opposite sides. So we're going to collect them together. That's like saying we're collecting like terms. So we now have 15 on the left side, and 2 positive is coming to the other side, becoming negative. So minus 2, and 6x is on the right side, and 4 positive is going out to become positive. 4 negative is going out to become positive, so that will be plus 6. Plus 4x. So, yeah, 15 minus 2 gives us negative. Gives us 13, not negative. I
That's it.
wonder where, yeah, I wonder where you got negative from. So 6 plus 4 is 10. So that's 10x. So we divide both sides by 10. Then we have x equal to one whole number, 3 over 10, or 1.3, not negative, because it turns to positive at the end, okay?
Yeah.
Okay, good. Now, the next one, which is number 2, we have 9x minus 5 equal to 1 quarter of 16x plus 60. What we have to do first here, because of the fraction outside, we open the bracket also, but the 4 is going to be at the base of the bracket. So we have 9x minus 5 equal to 1 times everything in bracket is still the same thing. Then over 4. Okay, this is simple. We can simply divide each one of them by the 4. So this is 9x minus 5 equal to 16 over 4 is 4x. And 60 over 4 is 15. Otherwise, we would have needed to cross multiply. But since we can divide them, then why not? Then it gives us something like this stage where we need to collect our like terms. So, having said that, we have 9x and 4x. So, 9x minus 4x equal to 15 is outside, and 5 is coming, I mean, to become 20. So 9 minus 4 is 5x equal to 20. Then I divide both sides by 5. 5 over 5. So x equal 4 and not 2.
I've got
Is
to
this clear to you?
change it to positive or negative. Yes.
Now maybe the negative and the okay you subtracted instead of adding. Okay, so um, put down the correction, then we look into something related to decimals.
Okay.
Here we have some decimals to change, some fractions to change to decimals. We have, this is number 1, that is 3 over 4. If you want to change this to decimal, there are lots of ways to, you know, you can do that in a lot of ways. The number one way is to just divide straight and say how many 4 can go in 3. It's impossible, so I have 0. Then I'm going to add an imaginary 0 here, making 30, okay? So how many 4 is in 30? That's 7, which is 28. So if I cross out and remove 28, I have 2 left, okay? Then I put another 0. That is 20. How many 4 in 20? That's what? 5. And it
5.
doesn't remain anything. Or we can say 3 over 4. I will try to turn this one at the bottom to 100, okay? How can I turn it to 100?
Okay.
I will say times 25, okay? You know,
Okay.
I'll say equal to 3 times 25 and 4 also times 25 because it's the base when I want to turn to 100. Is that clear? So whatever I
Yes.
now do to the base, I must do to the top. That is, whatever I do to the denominator, I must do to the numerator. So this gives me 75 over 100. And of course, this is 0.75, right?
Yes.
Okay, let's look at the second one, number 2. So you can use any of the method, but I prefer the first method instead of trying to say, is it going to be 100, is it going to be 1000 or something? Or what am I going to use to multiply? Now, number 2, you have 13 over 20. So I could say, how many 20s in 13? That's obviously impossible. I put an imaginary 0. How many 20 in 130? That's 6, which is 120. It's going to remain 10, okay? Then I put another 0.
Okay.
Is that clear? So how many
Yes.
20 in 100? That's 5,
5.
and it doesn't remain anything. So if you want to use the other method, you're just going to say 13 over 20, this times 5, 20 times 5 is 100, so 13 times 5. This is going to be 65 over 100, and this will be 0.65. So using any of the method, either method 1 or method 2, you can try to do the rest, okay? Exactly.
Yes.
So copy out the examples, then you do the remaining as classwork. Um, you Did you understand the number 1 to which number did I explain? Number 1, 2, and 3 that I explained. I mean, is it number 1 and 2 here? Do you understand it?
Number 2, the second example for each of them. That first one, I should be dividing it. That's why I don't understand.
Okay. Forget the second method. Let's stick to the first method. Do you understand the first method? Let me explain the first method. We have 3 divided by 4. Since 4 is bigger than 3, it cannot be possible. That's why I put 0, okay?
Okay.
Okay? Then
Yes.
I put a 0 by that 3, making 30. How many 4 is in 30? Tell me.
7.
Again,
7.
7. So what is 7 times 4?
28.
Remove it from 30. What do you have left?
2.
And that is the 2. Then you put another 0, making 20. So how many 4 is in 20?
5.
5. Do you understand this now?
Yes. What is that number
Okay.
12? Those odd numbers. I don't
Wait,
understand.
forget about number 12 or whatever. You're going to use the same method all through. Now, look at the second one. Do you understand this number 2?
Yes.
Explain it to me if you do.
20 and 13 is 0. Then you add the 0 on the 13. Then 20 in 130 is 6. There's 10 left. 20 is 5.
So that's what we got that. Okay, what I'm going to do,
Mm.
I'll do number 12 and replace it with another one. Are you fine with that?
Yes.
Okay. So this is what I'm going to use to replace number 12. This would be 13 over 27. So take note of that, that this will be your number 12. While I'm going to remove this one to do it up here. Since you were particular about, oh, that number 12, oh, that number 12. You see, so you have 13 over 27 to deal with while I'm going to work on this one for you. So for this number 12, 23, can 23 divide 15? The answer is no. That's why we put a 0. Then you put a 0 by the 15, making 150. So how many 23 am I going to see in 150? That'll be 6. And what is 23 times 6? Tell me. 20 times 6 is what? 120.
138.
Yeah, okay. So 23 times 6 is 138. So if I take 138 from 150, what do you have? I have 12.
On
So I put another 0 here, making 120. So in 120, how many 23 can I see in 120? I will see something around 5. So what is 23 times 5? That's 115, right?
one.
So if I remove
Yes.
115 from here, I have 5 remaining. So I put a 0 again. That will be 50. So how many 23 is in 50? That's 1, right?
Mm.
Remove 23
Yes.
from 50. What do you have?
Um.
Oh, that's 2, not 1. 23 times 2 is 46, right?
Yes.
So 46. Remove 46. What do you have? You have 4, right? Right? Can you hear me?
Yes.
Okay,
Yes.
so in 40, how many 23?
Yes.
That's 1. So if you remove 23 from 40, what do you have? That should be 17, right? So this will go on and on and on, and you can stop it on 2 decimal places, okay? So that means 15 over 23 is 0.65 approximately. Is that clear? You know, this is 2 decimal, so we can stop this one also at 2 decimal. That doesn't mean some will not give us 3 decimals, but at least if you show you're working like this and you peg it at 2 decimal, then you'll be marked right, okay?
Okay.
So you can see it's the same method. The method did not change. Now let us look at the ones you submitted. You said number 3 got 0.2. Yeah, 0.2 is correct because for that number 3, you have 1 over 5. 5 and 1 cannot go. You put a 0, that's 10. 5 and 10, that's 2. One is correct. And number 5 that you said you did says 0.4. Yeah, 2 over 5. 5 and 2, that's 0. And 5 and 20, that's 4. That's clear, right? And number 8, you said you got 0.8. Let's see. So number 8 is 12 over 15. I can firstly cut this down by using 3. 3 here, 4. 3 here, 5. Is that clear? Then 5 and 4, that's 0. 5 and 40, that's 8. Okay?
Okay.
So, and I said I was going to look at some more. Let me look at maybe one or two more. You skip number 4. Let's look at number 4. Then we'll round up for today. So for that number 4, what you have is 20 over 39. So obviously 39 can divide 20. So you put a 0 point, then you put a 0 at the top here, making 200. So how many 39 in 200? That should be 5. So what is 5 times 39? All right.
20.
Wait, let me see. Hold on. 200. We're looking for 39, right?
Yes.
So 5 times 39 should be what? That's 195. Okay. Is that clear?
Yes.
So that's 5 remaining. Put a 0. How many 39? That's 1. So remove 39 from 50. What do you have? You have 11. Put a 0 again. 110. So in 110, how many 39? That's 2. Okay. So what is 39 times 2?
2.
That's 78. Remove it from 110. What do you have left? You have 32. And so on. So you can stop it at, say, 20 over 39 is 0.51. Is that clear?
Yes.
So that means you're going to follow that method. You're going to do 6, 7, 9, 10, 11, and 12 against tomorrow. Is that clear?
Yes.
Okay, so I'm going to send you all of this correction. I mean, this page, so you do that as homework. Let me write homework. Homework. And that's where we'll be rounding up the class for today, Fair. Okay?
Okay.
So bye for now.